everyone is ready, I will start now.
Yep.
So, hello everyone. We welcome you to our final presentation on our tourism question answering system. Since we might have some new listeners, I want to start off by just introducing our team. We are a team of 7 Russian and German students. Obviously, we're not all at the same university. My name is Anna-Marie Wittig, and my other teammates will please introduce themselves.
My name is Vladislav.
My name is Daria.
My name is Alexei.
I'm Kelvin Duantin.
My name is Andreas Both.
And I'm Andrei Balak.
All right. So what is our system about? Our question answering, very simply said, is supposed to help and support tourists in planning their holiday trips or find certain locations such as restaurants or parks very short-term. So what will we see today? Today we will start off by explaining the motivation behind our project, just so you get an idea why exactly we're doing what we're doing. We clarify the exact requirements we had from the very beginning and take a quick throwback look at the phases our system went through. We follow this up with a quick demonstration of our system, just so you know what we're actually talking about before diving into the technical details, where we'll just talk about the used tools and frameworks, have a look at the architecture and components, have a little chit chat about our codes and see what the workflow of our questions is once they enter our system. After the technical part, we will basically check our quality measurements, just talk how exactly we did that, and conclude with just telling you what went wrong and what went good in our project and just give you an overall summary. So what was the motivation behind our project? Very basically, we wanted to support tourists by saving the valuable time they usually have to invest in web portals for researchers. If you are a traveler or a tourist or whatever, you really need to plan your vacations carefully because you have limited resources, be it time, be it money. But even with great plannings, there are always moments where you have to look up attractions spontaneously, which can be fairly annoying. And this is where our system comes into play. We want to offer an environment to support these wishes, these needs, while still being very easy to use and very simple to understand. Our initial requirements obviously changed over time, but this is like the one we had in our project call. And it was obviously to basically install a question answering system to search for travel locations that allow very specific, but also broader questions. Specific questions being like asking for certain places like restaurants, and broader being like asking for a little more broader, so things like fast food or maybe barbecue. For this application, we should use data of OpenStreetMap, which will be explained later on. And also, if a dialogue can't be answered easily, like if you ask for restaurants in Berlin, obviously there won't be the one answer. Our system should react accordingly. Lastly, obviously, we need a UI, so our users have actually something to interact with. And this UI should have a map and a visual representation of the textual results too. So what phases did our system go through? At first, we only had a simple first draft where we had the exact requirements figured out, defined like use cases, just so we really understood how it should work. Point out possible risks, since that's something we had to consider, and just overall define our workflow as a team, but also in our system. Secondly, we had a basic prototype which didn't have a UI yet, and only was able to answer very, very simple questions. We improved this prototype into a software in the third iteration, which could answer a lot more patterns, a lot more questions, and also had a first UI, which very simple, but visualizations on the map for the results, and also a dialogue window. In the fourth iteration, we then went on to fine-tuning, where we improved the UI, just made it all a little better looking basically, and started testing the applications and also correcting bugs, obviously, since we found some while testing. And this is basically where we are at now, but you will see it in the next slide.
Yeah, now I will show you our front end. This one. You see we split it into 2 parts. On the right hand side, you can see the big map. And on the left hand side, you see the heart of our application, the chat window. This part of our website connects the user to our chatbot. Also, you can see there are already 2 messages. Our bot asks in the first message for new questions or for our questions. And the second message says that we can type in help for some user instruction. This is supposed to assist the user to understand the website. So if I now type in a very simple question like, where's London? We will get a result after a few moments. That may take sometimes longer, sometimes it's fast. Our application is not really optimized for speed, so we have to wait a few seconds. So here we now see the three results. If I'm zooming out on the map, we see this little buttons, or buttons, icons. There are the locations of the three Londons on the world map. And on the chat window, we also see that we get some basic information. So the most popular London, of course, is the capital of the United Kingdom, so the first one. Also, we have a little button on the right corner of each result, where when we click it, we jump to the icon and to the result on the map. So we don't have to zoom in and zoom out. We also have some more complex questions, like show me museums in Hamburg. So of course, like Anne-Marie said before, we will get a large result. And if we get this result in a few moments, you see we have all locations on the map, but our system only show the first five results on the chat window. There we get the results. So you see on the map are in all results, and on the chat window only the first five. We also have this show me more button, which load the next five answers for the chat window.
Yeah. And of course, the application is complex and involves many parts such as data retrieving and visualizing. Also, we have provided a visual result for a user on a map. So for instance, as a programming language, Python along with Flask was chosen. And in order to make visual result, we've used a framework which is called Leaflet. And of course, our application must work not only locally, but remotely. So for this reason, we've used frameworks such as Canary and Docker. And in our system, we have some terminology, and probably you might be wondering what they mean. We have concept, entities, and pattern. So what are the concepts? Concepts is just certain features from an OpenStreetMap. They might be like bars, parks, bike rentals, and so on. Whereas entities just cities, organization, and some locations. And of course, we have a pattern. Well, it's obviously just a pattern of a question. For instance, a question may start with show me or show me nearby, and so on. And this is probably the most interesting part. So this is architecture of our application. So here you can observe three main elements. So we have our application, Canary, and our components. So Canary here is just sort of a bridge of the communication between the components and our application. So Canary also checks whether the components are working properly and ready for work. For instance, imagine that I ask a question, show me a supermarket. So firstly, the question will be stored in the Canary. And Canary has a database, which is called a start doc, where the result will be stored, and also to save intermediate results from the component's result. For instance, then Canary will provide a question for the first component, and concept identifier will find some concept inside the question, whereas pattern identifier will find certain patterns of a question, and in the end, the query executor will execute the final query and retrieve the result to the Canary, and then Canary provide the result to the front end, and user will see the final result. And also, we would like to a bit tell you about the components itself. Let's start with the entity identifier. So entity identifier just responsible for finding some certain entities in the question. Also here we've used the framework which is called Spacey, and it's just a framework for natural language processing which make the work a bit easier. And also we decided to provide a piece of code which you can observe. For instance, here I would like to pay your attention to some functions such as identifying and get access labels. For instance, we have some labels which we may find in a question, such as barbecue, ATM, shops, for instance. And then identify will just go through all this through list of the words and will find. If it finds the word, the result will be retrieved, so we will find an entity in this case.
Next identifier that we have is concept identifier. It picks up our concepts and find out with space match engine which of them are actually concepts, and with use of them gives them back to pattern identifier and query builder to actually complete our query to our street map and Wikidata. Next, please. Pattern identifier, it's actually our identifier to show what pattern user used to ask us a question. It gives us it gives users some variations what questions he can ask and what questions the system actually understands. It takes information from concepts identify and identify and builds with them a query that given back to query builder. Query builder actually creates the query string and takes all previous components into account and gives this query string back to a query executor, which actually executed to next please. Which actually executed to Overpass API and Wikidata API and gives back to user all information about what he wants to find and what system finds out about his question.
And responsible for whole interaction between the user and our system is AppPy, which is basically acts like an intermediator or the interface between the user interface and the backend. Every question that potential user types is calls to the AppPy, which have all the logic we need to interact with the canary. Also, it defines right sequential access to our components. After canary finished its processes, then it gives the results back to AppPy. And here goes the output for our user. In the next slide is shown that frontend is written with the usual of the with the simple hypertext markup language HTML, and the JS is our scripting language. In general, the Flask framework is responsible for the whole work of our web application. The leaflet is responsible for displaying the map. A map, all displayed markers, a scale, map position, and other features are available because the leaflet capabilities. In the next slide, it will be shown that we have a question. So on the main page, which is AppPy, like I said before. So user types some question, AppPy sends it to the canary. Canary gets that question, and that question then canary processes and interacts with each and every component of our system. And the first is, like you see, the concept identifier and the entity identifier, which work a little bit exactly like they got the text, they return some concepts and entities in the next ways you see, like key and value, text and label. Then we get the pattern identifier, which gets the question text again, but now with the concepts and entities which were processed before. It returns pattern PCA, and that stores in the canary. Canary then sends everything we need, like these pattern concepts and entities if they were, to the query builder. It processes them and returns a query. Then we have a fully executed query, which we output with the use of the AppPy, and the user see the actual result.
Next, I want to tell you about quality measurements. We check the questions automatically and manually. In total, we checked 461 questions. All results are stored in Canary. In other words, Canary stores the result as is the outputs for each component or not. Pattern identifier works with 99% probability. Query executor works the worst. However, the results of this component depend on the results of previous components. In addition, a question cannot have an answer. On the next slide, you can see examples of questions that work. The system handles these questions correctly. For example, where is Berlin, location of Berlin, restaurants in Berlin, show me bars in Amsterdam, and others. Next, please. But there are also issues that the system cannot handle. For example, show me Berlin or show me hotels in Paris. This is due to a feature of the model that Space uses. For our system, we chose a model that works faster than other models. To solve this problem, we can choose one of the other two models from Spacey or use own classification model. Parks in New York and where is Marseille don't work because New York and Marseille are not capitalized. The slide below shows the main reasons why our system cannot handle questions. The first, capital and italical entity letter problem. I think this is clear. Some words written with italical letter have a different meaning. Spacey, as I said, it depends on the model we have chosen. We can choose one of the other two models from Spacey or use own classification model. Entity language problem. Some entities can only be recognized when they are written in their native language. Missing entity description in OpenStreetMap. This means that OpenStreetMap is missing some of the text that we use for our identifiers, and also the system cannot handle umlauts and other characters that are language features.
And so we come to the conclusion. Yeah. What was good in our work? First of all, presentation. We hope that they seem very beautiful and informative to you, and during the presentation, we really work all together. The next item is deadline working. We think it's no secret that the general tension and concentration increase in front of the deadlines. So at such moments, we worked 120%. The next 2 points are Docker and frontend. We are very lucky that Calvin in our team, he was responsible for these parts and he performed the work just fine. And last, but perhaps most important, we understood the concept of components, understood how Canary can help with application development and how the application can be scaled by simply adding new components. What was not going well? We are an international team, and unfortunately, we simply couldn't understand each other. Therefore, at first, we had big problems with communication and time management. The next item is small development related issues, namely NLP and server problems. These issues have been fixed, but you have already seen that we have some latencies and we still have room to grow. And at the very end, is the next slide, please. Yeah. Thank you very much. And at the very end, we would like to say that despite all the disagreements and problems that our team faced, we are very proud to have participated in this project. Now we have a product, we have question answering system with visual representation and dialog window, and it works. And we are able to overcome our inner demons and gain very valuable experience. Thank you very much. And now we are ready to answer questions.
thank you for this well-timed presentation. Thank you for a good structure as well. Are there any questions from the people who have heard this presentation?
Maybe I have one. Could you please switch to the slide with entity identifier code? Okay, so no questions.
Okay, to give you time to think about another question, because we have enough time to do so, I would like to ask a question about the quality. Can you switch to the one of the later slides? Exactly this one, the quality measurements. So you discussed here the quality measurements of several questions. Can you give us some insights how you have created these questions and what might cause the problem of, for example, these components? Some of the problems were already discussed who are related to, for example, to Umlaute, which are well, very specific for the German language, but maybe you can give us some other insights, what causes problems on these components such that the quality is dropping here. So first question, how you have created the quality measurements. Secondly, what were your insights in relation to the quality problems?
Okay, so obviously we had the automatically checked questions, but the manual checked questions we had some where we just basically ran through many of our patterns and just inserted a list of concepts which we thought should have used worked that, and some concepts just in general didn't really work, and especially like actually the written in, how is it called, uppercase and lowercase, where the hue even with the concept was sometimes quite the issues, especially when it came to castles, I think it was.
Also, I wanted to say that we then have found the fix for our system. Like there are the results of the previous version. We thought that in March we updated the latest, but recently we discovered that it's not so, and now we consider it will be incorrect to accept any changes because the project was supposed to end a few months ago. So the results could be much better because the problem is fixed, but yeah, this is what we have.
Regarding your manually checked questions, why did you not automate those as well?
Excuse me, regarding what?
Your manually checked. Yeah, you've got some manually checked questions. Like you've got some automatically checked questions and some, I think, 243 manually checked questions. Why did you take all this work? Checking 243 questions?
Sorry.
Yeah.
Actually, that is because if we just check it automatically, we can't really see if the bubbles on the map are actually right. Like in our very first version, for example, we had an issue where if you searched for Leipzig, like some city, you would end up in Berlin, and we needed to see that with our eyes to be sure that it's like, you know, not the completely wrong city, obviously.
Yeah, sure. Thank you.
I have a question too, Michael Schmidt, my Name. I'm only a listener, not a student. My question, maybe I missed it, is how or where did you get your knowledge base, your entries, your locations for your work?
OpenStreetMap, we parsed all the features from their wiki page and we used this data.
So also restaurants and hotels and so?
Yes, there are a lot of features, like more than 1,000, as I remember.
Okay.
If there are no other questions, I would like to ask another one. So you have given us this very frank impression, also shown via live demo, that the system was not optimized for the performance, but it's completely okay because the task in this module, in this course, was to actually show that you are capable of implementing such a system, but not to focus so much on actual performance optimizations. However, maybe you can give us some insights what these performance issues, what was causing these performance issues. So what was the reason for having not the best performing application?
I think this is because we use spacey matcher, and this is the main problem, I think, because we could actually create our own classificator or make it based on the neural networks, and it will be much better than actually use the rule-based approach, because like the whole system is relies on it, and there are so many components that we use all the time. They over and over again loads the NLP and do the same stuff that we could do just once by using some training feature or the model. I think this is one of the common things.
And I think at least using the external API would also cause some, at least some additional time due to the remote service. First of all, to the remote service, and secondly, because while you are sometimes asking very complex questions, which also will take some time for OpenStreetMap to answer.
So did you measure your different components, and did you go a path from the asking the question until the answer is was showing to the user, so as I understand, you had a lot of different components, and you have to measure on which component took the longest time in your complete cycles. So did you that, or did you only saw did this took too long altogether?
The whole one of the components that defines that is the last component, which is query executor, and there is like sometimes where you type something like "show me restaurants in Berlin" or something like this, there could be like 1,000, 2,000 or more even results. And to draw that on the map and to receive all that array of data from the external server is very complicated. And this is the main problem, I think. If we could use a local database, not that belongs to somewhere else, that it will be much better, I think. Or if we just say, okay, we have some time, like a half of second, then when the half second ended, then just show me results. But now what we do, we just wait until all the results will received, and then we show them.
Okay, but you don't have the you don't have different measurements, for example, for the part that Spacey did for NLP and the part of receiving the data from the API?
We actually did it half a year ago, like for each component, and they were like about 1 second to perform. Each of the component plus minus were the same, except the latest one.
Okay.
And for all the listeners, I would like to add that the time measurements are also provided by the Canary framework. So if we would have put some attention into this direction, it would be possible to retrieve from the cheapest store that is used by the Canary framework to retrieve the time that different components actually have took for doing their actions. So data is there, but as I said, it was not the core task in this project, or in all of the projects in this course. Okay, so we did it perfectly in time. Thanks a lot for the project team for this excellent presentation, and to all of you for the excellent discussion. I would now like to ask for stopping the presentation.